So what we're working on today is we are working on putting a quadratic into the vertex form, which we're going to review again. We've done it before, so we'll review it again today, by using the completing the square method. So it really ends up helping us review both of them, vertex form and completing the square. So this is a question that is asked actually quite a bit on the Regents exam. They'll give you an equation, and they'll be the short answer questions, but you have to show your work. And they'll say, put this in vertex form by completing the square. So then this is the method that you would follow to do so. So what we would do is we would start off making sure that we are in standard form. Since we aren't solving for an answer this time, we're just changing from one form to the next. You want to make sure it's y equals ax squared plus bx plus c. Sometimes instead of a y, you may see function notation, so it would just be f of x equals instead of your y equals. But it still needs to be ax squared plus bx plus c. So that still needs to be in order. So just like in completing the square to solve, you would first move your c term over. So that's what I did to there. So y is still there, but I still move that constant term over so that everything with an x is still on one side of the equal sign. Everything else is over on the other side of the equal sign. Our next step, just like before, we would put our spaces in there so that we can do our completing the square. Your number that goes in the space, you would figure out the same way that we did before. You take your number in the middle, your b term, divide it by 2, and then square it. So it's the same process to get that number there. Once you have that filled in, you factor the left side of the equation, just like we did with our other completing the squares. And then you just move your constant term back over so that it's, again, y equals, and everything else is on one side of the equation. So let's take a look. We're going to put the following equations into vertex form by completing the square, and then we are going to state the vertex of the quadratic. So again, let's take a look. Yeah? Yes. But first, are we in standard form? Yes. It already is. X squared x and then the minus 5. So our first step tells us add that constant over. So we're going to add our 5 over. So I get x squared minus 2x plus a space equals y plus 5 plus a space. Y is still there because we didn't do anything to it. We just add the 5 and the space. So what is our number that's going to go in the space? 1, because half of 2 is 1. 1 squared gives us a 1. So it's a 1 and a 1. So now the left side factors into x minus 1 squared, just like it does for all of our other completing the square factoring. Over here on the right side, we would have a y plus 6, because the 5 plus the 1 gives us a 6. So now, since we're not solving, we're just putting it in vertex form, I'm now going to bring this 6 back over here. So I have x minus 1 squared minus a 6 equals y. So now our equation is in vertex form. The other thing our directions told us to do was to actually state what the vertex of our parabola was. So what you have to remember, we refer to these letters as h and k because there's already an x and a y in there, so they couldn't use those letters again. They use h and k. So h is the x part, but you change the sign of it when you take it out of the parentheses. So of our vertex, the x value is 1. The y value would be the negative 6. That one outside keeps its sign. So the vertex is at the point 1, negative 6. And there we go. All right, let's try this one again. Are we in standard form for number 2? No. So we should add this x squared over first. So x squared plus 5x minus 15 equals 0. Then what should we do next? Add 15. get x squared plus 5x plus a space equals y plus 15 plus a space. What number goes in the space? It's going to be a decimal. 6.25, because 5 divided by 2 gives me 2.5, and then when I square 2.5, we get 6.25. So when we factor this left side, some people freak out because it's a decimal, but remember, it's just whatever half of that 5 was, so it's x plus 2.5 squared. And then it equals y plus 21.25. And then what do we do with our 21.25? Subtract that back over. So x plus 2.5 squared minus 21.25 equals y. There's our vertex form. So what is our vertex? Negative 2.5, because remember the x part of your vertex changes sign values when you take it out of that parenthesis. And then negative 21, oops, I ran out of space, 0.25. That would be our vertex. All right, number 3, we got y equals negative x squared plus 10x minus 15. It is in standard form because it does go x squared x and then your constant term. However, we have an extra step we have to do here. We can't do completing the square with the x squared term being negative. So what we want to do, and I have the little note over there, we're going to divide everything by negative 1 because then that's going to change our x squared to be positive. So we're going to have negative y equals x squared minus 10x plus 15. So now we're going to follow the same other steps we've done before. So we would subtract our 15 over to here. We have negative y minus 15 plus a space equals x squared minus 10x plus your space. What number goes on our space? 25. So over there on my left side I have negative y plus 10 because, you know, my negative 15 plus my 25 gives me a 10 equals x minus 5 squared. What do we do with our 10? Subtract it over. So I have negative y equals x minus 5 squared minus 10. But I'm not quite done yet. Not negative y. We're going to multiply times negative 1 because we got to get that y value back to being positive. So this makes it a positive y. I can't actually distribute that negative 1 through my parentheses because the parentheses are squared. So order of operations, I would have to multiply that out first and then I could distribute the negative 1. But we're not going to do that because we want it to stay squared because we want vertex form. So the negative 1 just goes out in front of it. And then our negative 10 turns to positive 10. So now it's in vertex form. This one's a little different than the other ones because your a value here is a negative 1, whereas your a for all the other ones was a positive 1. So what's our vertex? 510.